switch. We are deeply honored by the gracious presence of our distinguished dignitaries, TOT partners, senior officials, scientists, and invited guests on this occasion. We are honored to have with us Air Marshal Tejinder Singh, PBSM, AVSM, VM, Chief of Integrated Defense Staff, as the chief guest. Welcome to CSIR, sir. Yes, ma'am. We are happy to have with us Dr. N. Kalai Selvi, Secretary DSIR and DG CSR on this occasion. Welcome to the event, ma'am. I also welcome Dr. Abhay Anand Pashilkar, Director CSIR-NAL for today's program. I now request our director to welcome our chief guest with a flower bouquet. I also request our director to welcome our DG ma'am with a bouquet of flowers. Thank you, sir.
Primarily developed at CSIR-NAL with our own resources as well as funding from CSIR. Air Marshal Tejinder Singh, PVSM, AVSM, VM, is a graduate of the National Defense Academy and was commissioned in the fighter stream of the Indian Air Force in June 1987. He took over as Chief of Integrated Defense Staff, the Chairman, Chief of Staff Committee on 1st July 2026, after relinquishing the command of the Southwestern Air Command of the Indian Air Force. He's an experienced fighter pilot and a Category A qualified flying instructor. He has been a DS at the Flying Instructor School and the Air Force Examiner at the Air Crew Examining Board. He has 4,500 hours of flying service and has flown various aircrafts, including Jaguar, Hunter, Kiran, HPT-32, etc. He's also qualified as a second pilot on the Cheetah helicopter. He's an alumnus of the Defense Services Staff College and the National Defense College. He has held key appointments of Flight Commander as well as Commanding Officer of Flight Squadron, Station Commander for Radar Station, Air Officer Commanding of a major fighter base, and Air Officer Commanding Jammu and Kashmir. The staff appointments held by him include Ops 1A1 as an operational command, DPO, Air Commodore at various levels, at Air Headquarters, DAC IDS, at headquarters of IDS, ACAS Ops Offensive, ACAS Ops Strategy at Air Headquarters Vayu Bhavan, Senior Air Staff Officer at Headquarters Eastern Command, Deputy Chief of Staff Air Headquarters again at Vayu Bhavan, and Air Officer Commanding in Chief at Training Command. Prior to his present appointment, he was the Air Officer Commanding in Chief at Southwestern Air Command. For his distinguished service, of course, he has been awarded the Vayu Sena Medal in 2007, Ati Vishisht Seva Medal in 2022, and Param Vishisht Seva Medal in 2026. He's, of course, married and has a son and daughter. He's an avid reader and pursues cycling and long distance running. We also have among us Major General Amit Talwar, SMPSM, Assistant Chief of Integrated Defense Staff, PP and FS. I welcome all of you, sir, and other officials of the IDS, as well as our TOT partners, the project team, and all uh, heads of divisions at CSR and other directors who have come here to make this gathering a success. Thank you. Jai Hind.
Thank you, sir. We shall now have a presentation on the microgas turbine engines developed at CSIR-NAL, highlighting the technological development and capabilities achieved by the lab. I now invite Sri Pratapanaika, Scientist G from CSIR-NAL, to make a presentation.
So good morning to all. Please load. So I will briefly present this family of jet engines which are developed at the CSIR-NAL. So we have developed three engines in this series, and fourth, as per our defense requirement, the NJ150, that we are planning to develop next. So next slide. So this is a test facility which is established at CSIR-NAL. So all these engines which are undergoing the testing at this facility at CSIR-NAL, this facility is capable of testing up to 300 kg of jet engines in currently. Next slide. Okay. So first in this family of jet engine is this NJ5. So this is configured using the centrifugal compressor, vaporized combustor, axial turbine, and convergent nozzle. So this is running at 1 lakh RPM for producing the 5 kg of 5 kg of thrust, and this can go up to 1 lakh 17,000 RPM, where it will produce 7.5 kg at the sea level. So this is having a variety of applications where kamikaze drones, hard kill applications, are power plant for subscale models. And this is ab initio design. Just I am showing the how compressor design, the aerodynamic design, mechanical design, and performance maps are plotted in this slide. And this is a turbine design. This also contains aerodynamic design, mechanical design, and performance map. And the combustor, nozzle, all these things are designed in-house. So we have developed it's a prototype 4 because it's modified from prototype 1, 2, 3, 4. Like finally, fourth prototype is the flying prototype. So this has undergone several tests in the test bed. So this is a testing video. So after testing this, the question remains whether this is whether flyable. For that, one model aircraft was designed. So here, the bottom you can see this is a model aircraft. This also can be a product, and this we have tested using this model aircraft. This can be used for a high-speed loitering and also this can carry 500 to 500 gram to 1 kg warhead, where it can use for a hard kill also. This will be very effective when it goes for a swarm applications. And the second in the family is 100 kgf. This is also similar platform we have adopted there: centrifugal compressor, vaporized combustor, axial turbine, and convergent nozzle. So, but it's a 100 kg engine. The design is completely from scratch we have done, and this is having a 50,000 RPM, which produces the 100 kg of thrust, and this idle speed for this is 10,000 RPM. So this can be used for a little higher application, potential application, even subsonic cruise missile for up to 500 kg of 500 kg all of weight. That class cruise missiles also can be developed using this, and this can be used for target practice drones, high speed drones, and interceptors. Decoys also it can be used. So here again I have plotted the compressor, how it was designed, so initially CFD, then structural analysis, the performance map. Here we can see 16.55 stall margin it was having, and then vibratory characteristics of the compressor. Then turbine design. So this is also done from the CFD design, CFD, then structural design, then performance maps are plotted, then its vibratory characteristics, how it behaves in while running. And this is a rotor system. So these are all required for designing the engine. So then this is one of the critical thing. Actually, these engines works at very high elevated temperature with higher pressures. So working geometry and fabrication geometries are totally different, because fabrication geometry, when it undergoes this high temperature and high pressure, that will distort. So for that, this is one of the important steps when we are designing the engine. That is what plotted here. And the potential use, that's always people are asking. You can see this is one of the missile where 500 kg all-up-weight missile can give a payload of 200 kg, and this can travel up to 1000 kilometer, and it will cruise at zero point 0.8 Mach number at very low altitude, where it can evade the radars. And this particular vehicle can be used for different applications, like with the moving targets with seeker, and also laser guided vehicle for the fixed targets, as well as this can be used as a decoy to confuse the enemy during the conflict time, because this can fly up to zero point 0.8 Mach. By changing the electronics, it can easily confuse the enemy for fighter aircrafts. And this is a test data for various builds for this 100 kg engine. Then third one is in this series is 50 kg engine. Similar configuration we adopted using centrifugal compressor, vaporized combustion, and axial turbine. However, here it's very compact. You can see it's just 175 mm is the diameter. This is just above the half feet, and this is just weighs around 5 kg. So very compact engine which gives the 50 kg thrust, and it runs at 80,000 RPM for a design thrust condition. And this is for a, as explained earlier, same compressor design from scratch to still final production. And this is a turbine design and combustor design, as well as the nozzle design with rotor system. So this is a test. It's now undergoing in the test bed of NIL, this 50 kg. And one potential use is this is a jet platform. What we thought is, because this platform can operate autonomously for our Leh Ladakh, there hilly regions where without any condition like fog condition or night, it can easily travel where other means of travel is very difficult. This can carry up to 150 kg payload. It can send the food supplies, medicine, or it can even move the troop also. That kind of application we can make here. 6 inches, 3 inches this side, 3 inches that side. NJ50 engines are used for this design, and this can move bottom. There is a thrust vectoring, small nozzles are kept. So this is this kind of potential application where our Indian problems are different compared to others. This kind of vehicles are very rare. This is one of the potential application where this can make a impact. And this also can be used for a so interceptors, low cost interceptors. Now that is a major issue now, because drones are coming 500,000 like that in the conflict time. So this can become a very low cost interceptors, because it moves faster because of jet engine compared to prop engine vehicles. This can be effectively used in the scenarios. So to conclude, so all this CSR, NIL turbojets are ab initio designed. They are from the scratch. We have actually developed the expertise in this area for Atmanirbhar Bharat. So manufacturing ecosystem developed for this class of engine within the country. Established engine bearing manufacturer, which is very critical. So when we started 100 kg engine, we could not get the bearings at all from foreign OEMs. So then this really strengthen our strategic weapon development. And because this engine has no dependency, we are using the material available in Indian market, and there is no limit. So this can be scaled up to any number, and it can be used effectively for our defense. So thank you very much.
Thank you, sir, for your insightful presentation. I now invite our esteemed leader, the DG CSIR, to address the gathering.
Namaskar, Vanakkam, and pleasant morning to each and every one of you. Today is a very, very special day, not only to CSIR-NAL, but also to the entire CSIR family, because the day is really blessed by the esteemed presence of Air Marshal Rajinder Singh Ji, and also the esteemed officials from IDS, and also from Navy. And apart from that, few industry partners, stakeholders, TOT counterparts, and my CSIR family, all of us are going to witness the launch of very important and a very important invention or discovery, or I would say the technology lead that has been really come up by, developed by CSIR-NAL is getting displayed today. And this is a great occasion for each and every one of us to understand more about what is going on in CSIR-NAL and what is the purpose for which CSIR-NAL is taking this kind of a work and what kind of a technology that they are going to offer to the nation, especially considering the current as well as futuristic strategic requirements of this country. Air Marshal Ji, I would plainly say, just to understand your complete portfolio and your resume, I think we need a dictionary. The time when NAL director was introducing you, I was finding it very difficult to understand many terminologies. Reason being, you not only flew to greater heights, but also you have touched and achieved greater heights in your career also. So I think we should give a big round of applause to Air Marshal, because with that kind of background, capability, strength, knowledge, experience, and exposure, today he has made up his mind and adjusted his calendar and time to come to CSIR and to encourage the entire team of CSIR-NAL, who is coming up with a series of success stories in the name of micro gas turbines. As all of you are aware, they have already developed Wankel engine also. Today they are talking about only micro gas turbines. They made all of us to understand what is NJ5, what is NJ100, what is NJ50. Of course, 150 he did not talk about. I think he is developing it at the lead stage. But one thing that we can really appreciate is today's era is the drone era. So to what extent drones could be powered is one. And the second challenging thing is from the warfare or from the security and the strategic point of view, these drone interceptors are also playing and they are also assuming critical importance. And therefore now CSIR-NAL is coming up with this kind of series of micro gas turbines, which will definitely find a special place and very specific applications in drones related applications. So instead of we from CSIR coming out and say that we have done A, B, C, D, E, which will be finding its application in A to Z areas, it always looks like we are patting on our own shoulders. And therefore we thought that it's better to listen from the other end, from the user point of view, from the ideas viewpoint, from the strategic viewpoint, from the defense side, how do they really weigh it? How do they really market? How do they really celebrate it or expect it or anticipate it? Or what are their futuristic requirements? With that kind of a curiosity, today's meeting assumes greater importance. And taking this opportunity, I should thoroughly appreciate Dr. Abhay Pashilkar for his dynamic leadership and also the scientist who made the presentation. And whenever I'm giving this kind of an appreciation, that should be owned by the entire team of CSIR-NAL, because by taking help from every possible sector and from every possible employee of CSIR-NAL, they're able to showcase this kind of a success. And Air Marshal Ji, just yesterday evening, I happened to attend one meeting which was chaired by the Cabinet Secretary. Now, country is coming up with a list of 100 plus products which are to be indigenized on priority. And DPIIT and DSIR, we both have been given this kind of a responsibility to talk to different ministries. And final presentation was made by DPIIT in the meeting yesterday evening. So there we had detailed discussion for strategic requirements related products also. At that point of time also, I fondly recalled 2 years back, Abhay Pashilkar was also there in that meeting. So the then minister, he just made a mention that you guys are not at all giving importance for indigenous engine development. All the time we are depending upon other countries for our engine requirements. Even now for their Hansa NG, which is a two-seater pilot aircraft, trainee aircraft, for that also engines we are depending upon one particular company. It is from Austria, I believe. And all the time we had difficulty in getting that particular engine, and they are making it as a very special mention. They will give it only for civilian purpose and not for defense applications. And in the entire country, the supplier has decided that they will give the supply only to NAL, believing that NAL is working on the civilian aircraft applications. And initially they gave only 5 engines and we started our journey. And now this Hansa NG, that technology has been already given to the production partner. Production partner started making this aircraft. And now we have orders to the tune of 135 in hand, and 350 is the order which is expected in another 5 years. But we are not having engines which are produced within India, and still we have dependence on the other country. And now with great difficulty, initially they did not say yes to that. At the max, they said yes for only 10 number of engines. But finally, we took special efforts, and with the intervention of the Prime Minister's office, finally now the company has agreed to give us the supply of 135 for all the aircrafts which are going to be manufactured indigenously in India using NAL's technology by the production partner identified by CSIR. So to get this kind of a supply, we have to make this kind of an extra mile efforts. And therefore, to put an end to all these things, it is the time, critical time, that India should come up with our own indigenous production of engines. And that is why CSIR-NAL has really prioritized this particular area. And I'm extremely happy, Abhay and his team, they have come up with a series of micro gas turbines apart from Mancall engines. And now, if at all they are given suitable, I would say, support in terms of technical specifications, financial support, and finding the right choice of partners to work with, and to come up with the proper choice of TOT stakeholders, they'll be able to showcase more and more success stories. And I'm just making it as an appeal to defense and the Navy family. So just before we came here, we had a 5-minute talk, and we also agreed upon few points. And by putting together all these things, this is a very proud moment for all of us. So let us celebrate the success of this kind of micro gas turbines, which were totally indigenously developed, designed, and completely developed, demonstrated by NAL. And one point which I like the most from the PPT is the PI said that they have used whatever materials which are available in Indian market. So meaning is we will not have any problem with respect to the supply chain, and whatever materials which are available in the market, they have used only that material, and finally they are coming up with this kind of a technology. Hearty congratulations to NAL family. And with this one, I really request Air Marshal Ji to come and just launch this particular product. Please get it inaugurated with your gracious presence. Thank you so very much. I'll join you. You also join? You also join? You are NAL family. Come. No problem.
We will watch a 2-minute video on the micro gas turbine engines. Thank you. It's now our privilege to hear from our chief guest, Air Marshal Tejinder Singh, PVSM, ABSM, VM, CIDS to the Chairman, Chiefs of Staff Committee. May I respectfully invite our chief guest to address the gathering, please.
Dr. Kalai Selvi, Secretary DSIR, and DG CSIR, Dr. Anand Ajay Fansilkar, esteemed scientists, entrepreneurs, engineers, technology leaders, friends from the media, uh, my friends in uniform, and ladies and gentlemen. I feel extremely happy to be here today. And of course, we'll make sure that the biodata is a little smaller next time so that, it is sounding more, awing than probably it is. Most of it is routine, ma'am. All of us go through that. But we all remember right from our childhood days, general knowledge. We remember who made the first steam engine, who made the gramophone, who made the telephone. So there is an inherent excitement when you see something being made and discovered. eh? So generally, as individual and as an Indian citizen, I feel extremely, extremely proud at your achievement. My kudos to all of you. This particular uh, product, the engines that you have made, is especially very close to my heart, or for that matter, especially for the Air Force. Reason being that this is one capability that has always come in the way of our acquiring operational capability. Uh, we are all aware that despite the beautiful LCA car that we have had, our dependence on an imported engine is slowing our acquisition. In fact, uh, because we don't have the capability to make aero engine, we first decide which engine is there and we decide an aircraft around that. You know? So that has been the bane. And I was one of the appointments which was called, I was ACS Offensive Ops. I was involved looking after the RPS, the drones, UAVs, you would say, that time. So at that point in time, when we are doing a review of the project Tapas, one of the stumbling blocks because of which that had to be foreclosed was that it couldn't climb high enough because we didn't have a appropriate power plant. In fact, anecdotally, I can't verify this, but in that discussion, it emerged that we even considered using two engines of the Tata Sierra car for powering the Tapas, but for that also we could not get the TOT from within our own country. So, in the import of that, these three engines and the plan for the future and bigger one is a watershed moment as far as we are concerned. The recent conflicts, you would have seen the proliferation and the widespread use of unmanned platforms, drones, loiter munitions, and missiles. And the power plant, which is the heart of all these systems, would probably, some of it would be in these categories, and I'm sure you'll be able to develop bigger ones, better ones, which meet the nuanced specific requirements on that. So I'm extremely elated at this discovery. I would urge you, like we had a discussion, that let's quickly make a product, with these engines that is flying, and rather than take some time to develop the other aspects. Let's quickly collaborate with our the other capabilities are by and large available in the country. There are a lot of people making drones. There are a lot of people making subsystems. There are people who are making some kind of sensors. There are a lot of ITEX projects where we'll also share our TCPR, which we had a short discussion. So let's quickly make a product which uses these engines and is flying. We have the advantage that these will be used on unmanned systems, so the uh, certification requirements will be perhaps less stringent. Okay, in a manned platform, the challenge is different. The unmanned platform, that advantage is there. So we should, I think, do this is a critical requirement of the three services, not just the three services. even the paramilitary forces and the civil system requires these kind of platforms in large numbers, okay? And it will have usage not only in military as well as in the non-military sphere. So it is truly a watershed moment for all of us that you have made these engines. I would congratulate everybody who was involved in this, NAL, all the scientists, CSIR, and I wish you very much. I wish you many more successes in the same field. And truly, we are really proud of you. Thank you so much. Jai.
Thank you, sir, for your valuable address. We are deeply honored by your gracious presence today. As we come towards the conclusion of this memorable program, it is time to acknowledge and express our gratitude to all those who have contributed to making this occasion a meaningful one. It is my privilege to propose the vote of thanks on behalf of CSIR and NAL. First and foremost, we express our profound gratitude to our chief guest, Air Marshal Tejinder Singh, PVSM, AVSM, VM, Chief of Integrated Defence Staff, to the Chairman, Chiefs of Staff Committee. So your presence here today underscores the critical synergy between indigenous scientific research and national defence readiness. Thank you for your highly encouraging address and your continued support of native aerospace development. As a token of our appreciation, I request our DG ma'am to felicitate our chief guest. Thank you, ma'am. Sincere thanks to DG ma'am for her visionary leadership, constant guidance, and for providing the institutional backbone that enables such complex engineering projects to thrive. Thank you, ma'am. We also acknowledge the Director of CSIR-NAL for the warm welcome, and Sri Pratap Naika for the insightful technical presentation. And a special word of appreciation goes to the co-design, development, and technical teams at CSIR-NAL. We also thank head DGED and his team and the SSB Auditorium technical crew for ensuring the flawless execution of the program. Finally, we thank all the distinguished guests, invitees, and CSIR staff for your presence and participation. I request the distinguished dignitaries, directors, TOT partners, invitees, and HODs to join for a cup of tea at room number 101, and all other participants to be seated in this hall for refreshments. We will conclude the program with the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Yes, ma'am. I request NAL team to come on to the stage, please, for a group photo. I request all the dignitaries and invitees. Yeah. I request the defense team to join us on the stage.